Dear students, now we are in the topic system of circle. Today I am going to discuss with you the topic system of circle object. System of circle object synopsis, the concept and sums. System of circle object. Let us going to discuss about the formulae and concept. First of all, let us write a synopsis. First one, if two circles having equal radii, if two circles having equal radii cuts orthogonally, two circles having equal radii cuts orthogonally, then draw like this. This is C1, this is C2. Equal radii headed here. This is R and this is R. I want to discuss with you here. R is equal to C1 C2 by root 2. R is equal to C1 C2 by root 2. The formula now I want to discuss with you apart from I3. Whatever the formula are there apart from I3, I want to discuss with you regarding object. R is equal to C1 C2 by root 2. We know that angle in semicircle is 90 degrees. Draw like this. C1 put here P. C1P C2. C1P C2 is equal to 90 degrees. So in 90 degrees, draw like this, it becomes here, put here, this is P, this is C1, this is C2. C1, C2 we need, it can be represented as also D. C1P is equal to R and C2P is equal to also R. So D square is equal to R square plus R square. Whenever two circles are orthogonal, the condition is D square is equal to R1 square plus R2 square. Now we can write whenever the radii are equal, D square is equal to R square plus R square. So D square is equal to 2R square you can write, and R square is equal to D square by 2 and R is equal to D by root 2. R is equal to D by root 2. So what is D means here? The distance between C1 C2 in some books will be given like this. The formula, remember as the formula, this one as R is equal to C1 C2 by root 2. This is the first synopsis. Next, let us discuss about the length of common chord. This is not there in IP, simply common chord concept is there. Now I am going to discuss with you that length of common chord. Whether the circles are intersecting orthogonally or not. Orthogonally or in general mode, we can discuss the length of common chord. According to intersecting circle, let us consider intersecting circles. Put here C1, put here C2. This is the line joining C1 C2. Draw like this. This is R1 and this is R2. R1 and R2. Students, we know that the angle in semicircles, this is 90 degrees and this is a theta. Total I said that this is 90 minus theta. So whenever this is theta, this becomes 9. This is 90 minus theta. So total 90, and this is, if the angle between two circles can be represented as angle between their tangents. In the proof we have discussed that put here P, angle between radii. Hereafter you write as angle between radii. Angle between radii is equal to 90 plus, if the angle between, this is the 90 and this is theta, and then becomes, this is 90 minus theta. The small angle here or here you can take, this is 90 minus theta. Full angle is 90. If the angle between tangents is theta, this is 90 minus theta. So angle between radii you can write 90 plus 90 minus theta. It is 180 minus theta. Angle between circles you have calculated in proof. I said in exercise 2a concept. So first one is 90 and second one is 90 minus theta. So what is theta? Angle between the two circles can be considered as 180 minus theta. Then we can do one thing. Depends upon the area of triangle formula. You can write area of a triangle. Draw like this. This is the length of chord. This is m. The chord intersecting the line joining C1, C2 at midpoint. Here you can write area of triangle C1, P, C2. You remember this formula, angle between radii is equal to 180 minus theta. Depends upon 180 minus theta only. We have calculated the angle between two circles as cos of 180 minus theta we have taken, and the cosine rule we used in the proof. Area of triangle C1 C2 is equal to half into base into height concept. You write half into C1 C2 into height. Put here this is P and this is Q. Height PQ. Let it be area. That implies area capital A is equal to 1 by 2 into, put here C1 C2 means D and PQ means PQ. Simply give it like this. We put it as equation number 1. Now let us consider in another model. To calculate the length of chord, take area in another model also. Use delta is equal to 1 by 2 AB sin C concept. 1 by 2 AB sin C or BC sin R, CA sin B, like that concept you will use. So area you can write using this triangle. Area of triangle C1P C2. Area of triangle C1P C2 is equal to 1 by 2 into C1P into C2P. C1P into C2P into sine of that full angle C1P C2. That implies area is equal to 1 by 2 into this is R1 into R2 into sine 180 minus theta. Sine 180 minus theta. So here anywhere if you take here theta, so total 90 and this is 90 minus theta, 90 plus of 90 minus theta. You take this small angle is theta and this is 90 minus theta. So total angle should try to understand this is full 90, not 90 minus theta plus theta, students. This is small angle theta, this including 90. So this small angle is 90 minus theta. So becomes here 90 plus of 90 minus theta. Hereafter we remember the formula as angle between radii of the intersecting circles is 180 minus theta. Now you write 1 by 2 R1 into R2 into sine 180 minus theta becomes sine theta. So 1 by 2 R1 into R2 into sine theta, you write put this is 1. So area, now equate the first equation and the second equation. 1 is equal to 2, you write 1 by 2 into R1 into R2 into sine theta is equal to 1 by 2 into D into PQ. 1 by 2 both sides get cancelled here. PQ is the length of a common chord. PQ is the chord. You can write here PQ is equal to R1 R2 sin theta. Here H means not full H. This is only height, only half, not big. Here only PM is the height of this small triangle. So PQ becomes 2 PM. So PM you write. Better to write PM. So here that we can take PQ is equal to 2 PM. P not PQ. PM is equal to R1 R2 sin theta by T. So length of chord we can write total PQ. Length of chord PQ is equal to 2 into r1 r2 sin theta by what is d? Because this is 90 degrees in the triangle C1P C2, d can be written as r1 square plus r2 square using the right angle triangle property as Pythagoras theorem. R1 square plus R2 square. So don't forget students, this is the formula. Length of chord PQ is equal to 2R1 R2 sin theta by root of R1 square plus R2 square. This is an important MCET bit students. Don't forget this one. Length of chord is equal to 2R1 R2 sin theta by root of R1 square plus R2 square. Length of chord PQ is equal to 2R1 R2 sin theta by root of R1 square plus R2 square. Next, you can write this one as for 90 degrees. That is, if the circles are orthogonal. Let us write next formula, third formula. If the circles are orthogonal, then what is the length of a chord? Simply you can put third synopsis, right? If the circles are orthogonal, if the circles are orthogonal, if the circles are orthogonal, the length of chord. If the circles are orthogonal, the length of chord is equal to, put theta is equal to 90, becomes 2r1 r2 by root of r1 square plus r2 square. If the circles are orthogonal, length of chord 2r1 r2 by root of r1 square plus r2 square. Three formulas completed. Next, let us discuss about the fourth formula, that if P comma Q are conjugate points with respect to circle, if P comma Q, this is the equation exercise 2A, Roman number 2, fifth question. I did not say there. Now I am discussing here. If P comma Q are conjugate points, if P comma Q are conjugate points with respect to circle, if P comma Q are conjugate points with respect to a circle, S is equal to 0. P comma Q are conjugate points with respect to circle, S is equal to 0. If then the circle PQ has diameter cuts the circle S equal to 0 orthogonally. Then the circle on PQ has diameter. Then the circle on PQ has diameter, on PQ has diameter, cuts the circle S equal to 0 orthogonally. Cuts the circle S equal to 0 orthogonally. Let us draw the diagram first of all, then we can understand. Conjugate points means plenty of times we have discussed that pole of a line with respect to the circle should lie on the other. Otherwise, two lines are said to be conjugate lines if pole of the line, pole of P, polar of P lie on the Q and polar of Q lie on the P. Px1 comma y1 you take here. Wherever you have taken Px1 comma y1, then a secant line should draw to intersect the circle in two distant points. Put here A and B. Now draw the locus of points of intersection of tangent. Draw and extremities of chord is called as polar. So this is the polar of P. This is the polar of P. Next, take a point Q here. Wherever you have taken a point, then join the secant line should intersect the circle in two distant points. The tangent, drawn at extremities of chord that secant is called as polar. The locus of points of intersection of tangents. So this is the point of intersection of tangents. Draw like this. This is the polar of Q. This is the polar of Q. So here now you can understand that P and Q. P and Q as the circle which is having end points of diameter PQ. The circle which is having end points of diameter PQ is intersect the given circle S equal to 0. This is the circle S equal to 0 orthogonally. Now let us discuss the proof. Let the equation of circle be. Let us discuss the equation of circle be x square plus y square plus 2zx plus 2fy plus c. No need. Better to take small circle. So easy method. Let the equation of circle be x square plus y square minus r square equal to 0. This is better. Since px1 comma y1 and qx2 comma y2 are orthogonal. Since px1 comma y1 and qx2 comma y2 are orthogonal. Whenever two circles are orthogonal, then the condition is s12 equal to 0. The notation of s12 here x1 x2 plus y1 y2 minus r square equal to 0. x1 x2 plus y1 y2 minus r square equal to 0 because the 2 points are orthogonal. Now what is happening here? Qx2 comma y2. Now we are going to discuss about that. The circle PQ has a diameter. Whatever the circle PQ having diameter is there, that circle should cut the given circle S equal to 0 in orthogonal way. So now you can write equation of circle having end points of diameter, having PQ as diameter, having PQ as diameter. The formula we know that x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Let us expand this equation as x square plus y square minus x of x1 plus x2 minus x into x1 plus x2 minus y into y1 plus y2 plus whatever the remaining terms are there, that terms we should write as x1 x2 plus y1 y2. x1 x2 plus y1 y2 equal to 0. By expand this one, x square plus y square minus x taken common, x1 plus x2 minus y taken common, yeah, plus yes minus y taken common, y minus y2 becomes, yeah, y minus y1 like this, plus x1 x2 plus y1 y2 equal to 0 is there. Let this is a circle having end points of diameter. Let this is 1. Applying 2z dash plus 2f f dash. Applying the condition of orthogonality, it is called 2z dash plus 2f f dash equal to c plus c dash for 1 comma 2 right. I mean condition of orthogonality. So what is 2z dash? 2z means here there is no, not this is one, this is one. 2, this is 2 right. Better to use that one. So applying condition of orthogonality for 1 and 2. Now 2z means there is no 2z. 0 into here you can write x1 plus x2 by 2 plus 2f into 2f means also 0 into here you can write y1 plus y2 by 2 is equal to c1 plus c2. So what is c1 here? Minus r square is c1 plus what is c2 here? Here you can write this one as x1 x2 plus y1 y2. Try to understand that from 2 you write from 2. Here 0 is equal to, this is 0, x1 x2 plus y1 y2 minus r square becomes 0. So 0 is equal to 0. Hence the theorem you can write. This is the theorem. Hence the theorem is proved. What is the theorem? If P comma Q are conjugate points with respect to say given circle S is equal to 0, then a circle having PQ as a diameter cut the given circle into orthogonal way. Okay, let us discuss about the radical center concept now. Already we have discussed in IPE way that radical center we have discussed. Now let us going to discuss about the radical center concept. Radical center. We know that the radical center is the point of concurrence of radical axis. Point of concurrence of radical axis of three or more circles. So here we can understand that if S is equal to 0, S dash equal to 0, S double dash equal to 0, like three circles are S equal to 0, S dash equal to 0 and S double dash equal to 0 are three circles. Then the line L1 is equal to, this is L1. Then the line L1 is equal to radical x of S comma S dash, and line L2 is equal to radical x of S comma S double dash, and the line L3 is equal to radical x of S comma S double dash. This is the radical center, the point of concurrence of radical axis. From the radical, if any circle orthogonal to the given circle, from the radical center, put here P, put here Q, put here R. From the radical center to any circle is called as radius. It is nothing but length of tan. So we should calculate. We should write the formula synopsis 4 in this way that there exists a unique point. This is the formula. There exists a unique point such that the distances from that point to orthogonal circle are equal. What is orthogonal circle? Orthogonal circle is fourth circle for first, second and third. Like that, there exists only one unique point. That point is called as, that unique point is called as radical center. That unique point is called as radical center. Next one we can discuss about it. Same concept depends upon same concept. We know that since length of tangents are equal, lengths of tangents, that is radii of orthogonal circle, you can write. Radii of orthogonal circle are equal, then there exists a unique point. Such that L1 is equal to L2 is equal to L3. What is L1? Length of tangent from radical center to first circle, and L2 is the length of tangent from radical center to second circle, and L3 is the length of tangent from radical center to third circle. So there exists a unique point such that L1 is equal to L2 is equal to L3 for orthogonal circle, you can write. For orthogonal circle. of given three circuits. Of given three circuits. So in some cases, in some competitive exams, they will be given like the L1 equal to L2 equal to L3. The condition is dash. The point is dash. It is radical center. Whenever radical center is exists for a three circles, whenever a circle is orthogonal to the given three circles, then what is the value of lengths of tangents? Object will be given like this: L equal to L dash equal to L double dash, or L equal to L2 equal to L3 like that. The question will be given. Let us discuss about the concept of radical center having different triangles. So depends upon the three orthogonal circles. Three circles. Let us discuss whether the circles are orthogonal or not. Depends upon the formula regarding three circles. We can discuss about the radical center, position of radical center. Synopsis number 5. If A, B, C, capital A, capital B, capital C are the points on circle S equal to 0, S dash equal to 0, S double dash equal to 0. A, B, C are the points on the circle S equal to 0, S double dash equal to 0, S dash equal to 0, and S double dash equal to 0. Then radical center of three circuits having A, B, B, C, C, A, having A, B, B, C, C, A as diameters of circle is orthocenter of triangle ABC. It is the main point. Orthocenter of triangle ABC. Let us draw the circle, that too in intersect way. I am discussing with you as diameter manner, like this. From center to any point on the circle is called as diameter. Use the concept, students. This is A, this is B, this is C. So AB is diameter. AB equal to diameter. AB is the diameter of S equal to 0, and AC is the diameter of AC equal to dia, and here BC is dia of S double dash equal to 0. BC equal to dia. AB, BC, CA are the diameters of three circles. So orthocenter is the radical center of the three circles. This is the concept, important concept in objective fit. So what is orthocenter? What is the definition of orthocenter? The point of congruence of altitudes is called as orthocenter. So draw here a perpendicular line and put here A, B, C. Let us discuss. This is H, means orthocenter. Put here D, and in the similar way put here E. In the similar way, put here F. Now let us going to discuss about A, B, C, D, F, G, H over. Put here A, B, C, D, F, H is orthocenter. Put here this is P and this is Q. I am writing this one as PQ is the line joining centers. PQ is the P is the center, and Q is the center of, P is the center of first S equal to 0, and Q is the center of second circle. S dash equal to P is equal to center of P is equal to center of S equal to 0 comma Q is equal to center of S dash equal to 0. So what is happening whenever center exists for the triangle here, whenever B is AB is diameter and AC is the diameter. Diameter we know the longest chord passing to the center point. Center point is the midpoint here. So you can say here P comma Q are midpoints of P comma Q are midpoints of AB comma AC. We know that by Thales theorem in 10th class concept. By Thales theorem, we know that PQ parallel to BC. PQ parallel to BC, and we know that PQ is equal to 1 by 2 BC also. Of course, this is no need now. PQ parallel to BC is now. Already in radical center, I said that we know that radical axis, comma line joining center. Radical axis and line joining center are perpendicular. Whenever radical axis here, you can say AH perpendicular to PQ. That implies absolutely you can say AH also perpendicular to PD. So what is happening? PD became altitude. Similarly, we can say. Similarly, we can prove that. Similarly, we can prove that VH perpendicular to AC, and similarly, we can prove that CH perpendicular to AB. So, what is happening? All the lines AD, BE, CF are intersecting at a common point. Therefore, you can say radical center is orthocenter. Radical center is orthocenter. Radical center is orthocenter of triangle ABC. This is the important object bit, and it is a synopsis, IMP synopsis. Now, in the similar way, we can discuss about other radical center also. What is other radical center? So, if the three circles are orthogonal, if the three circles are orthogonal, then the radical center is also orthocenter, depends upon the same concept. Let us write sixth formula, sixth synopsis we can write. If the three circles are orthogonal, if the three circles are orthogonal, then radical center. Three circles are orthogonal, then radical center is the orthocenter of triangle ABC. Orthocenter of triangle ABC, where A comma B comma C are points of intersection. Points of intersection of circuits. In previous theorem also like this only. Points of intersection of circuit. Put here this is A, this is B. Draw like this. Draw like this. And this one. Whenever he given the three circles are orthogonal, whenever three circles are orthogonal, the line should be diameter. So perpendicular condition that we can say here angle in semicircle is 90 degrees concept. So here it is 90, here it is 90, here it is 90, here it is 90. So diameter should make the 90 degrees concept. Three circles are orthogonal mutually. So in the similarly, same as we can write, same as theorem 5. Same as theorem 5, radical center is equal to orthocenter. If you could not remember the formula, if you are unable to remember the formula, simply you can try to understand that whenever three circles are orthogonal, radical center is orthocenter. Whenever three circles depends upon the diameter of the triangle. Every diameter cuts the circle into two equal parts, which are called as semicircle. Every semicircle, we know that angle semicircle is 90 degrees. Ortho meaning itself is a point of focus of particles is nothing but 90 degrees. So easily you can understand that it is also orthocenter. So whenever 90 degrees concept is there, the radical center becomes an orthocenter. Remember this one as a formula. Next, let us going to discuss about another formula, seventh formula. Seventh formula. If three circuits touch each other, externally, then radical center. Three circles touch each other externally, then radical center is the in center of triangle ABC, where A comma B comma C are points of intersection of circles. Draw like this. Put here A. I mean here points of intersection of circles means A comma B comma C are points of contact also you can write. Points of contact. Of tangents also you can write, because whenever two circles or three circles touch each other, whenever the point of contact exists, there you can draw a point of tangent like this. Draw like this tangent. Now put here P. Let P be the radical center I am writing. Let P be the radical center. Let P be the radical center. So let PA comma PB comma PC, PA comma PB comma PC are lengths of tangents. PA comma PB comma PC are lengths of tangents. Lengths of tangents from P to the circles. That's all. Simply write circles, because circles means for S equal to 0 and S dash equal to 0. Both. This is for S equal to 0 and S dash equal to 0. This here S double dash equal to 0. So that is why simply write P to the circles. So PA you write. PA. Like this simply you write PB. You write PC. We have learned that there exists a unique point such that lengths of tangents are equal. Here L1 equal to L2 equal to L3. Here L1 equal to L2 equal to L3 means PA equal to PB equal to PC. Whenever PA equal to PB equal to PC, we can say that radii are equal concept. Where the radii becomes equal, for it is a circle. What is the circle? Touching all the three sides. The inside of the triangle is called as in circle. Therefore, the center is nothing but in center. Therefore, you can write radical center. Radical center is equal to in center. Here we learnt three cases. First one, if the circles depends upon the diameter of triangle ABC. So AB is the diameter of first circle, BC is the diameter of second circle, AC is the diameter of third circle. Then radical center is the orthocenter. And whenever the three circles are intersect orthogonally, radical center is orthocenter. And whenever the three circles touches each other externally, then radical center is in center here. Now, simple concept completed from our end, and next little formula is there. Depends upon the little formula that the formula depends upon permutations and combinations. After, let us discuss about simply formula. You will be learning the proof and concept everything in mathematics. Permutations and combinations after. Eighth formula. If there are n circuits, we need two circuits. We need two circuits to get radical axis. Radical axis you write. Because radical axis, I said that in day 4 yesterday class, I said that the definition of radical axis is the powers of points with respect to two circles are equal, whether it is inside or on the or outside of the two circles. So many circles may be like this. So many circles may be, but here it is radical. Here it is, here it is, like this. Between for any two circles, radical axis exists. So number of radical axis you write. Number of radical axis equal to MC2. This is the formula. C for combination or selection. If there are n circles are there, to select all things from n things is formula NCR. Selection or combination. Selection or combination of all things. Selection or combination of all things among n things. All things among n things is equal to formula NCR. So for exist radical axis, we need two circles. If there are given n circles, the formula is NC2. Next, ninth formula. If there are n circles, we need three circles. If there are n circles, we need three circles to get radical center. Because I said the definition that radical center is the point of concurrence of three radical axes of the three circles. So here, according to permutation combination formula, that is equal to MC3. In next step, I am writing the number of radical centers. Number of radical centers is equal to MC3 is the formula. In some cases, there is a chance to give the question like that: if number of radical axis equal to number of radicals. Before going to discuss, I want to discuss with the formula. If NCR is equal to NCS, then R is equal to S, R plus S is equal to N. Now, this is the formula. Let us discuss the importance of number of if number of radical axis is equal to number of radical centers. Number of radical axis equal to number of radical centers. This is MSET based question. Then number of circles equal to dash. If number of radical axis is equal to number of radical centers, the number of circles equal to dash. So number of radical axis formula NC2 and number of radical centers NC2. Here use the formula if NCR equal to NCS, R is equal to S, R plus S is equal to N. Here R is equal to S means 2 is equal to 3 is wrong, absolutely wrong. The templates you can say here according to that formula 2 plus 3 equal to 5. So N is equal to, here you can write 2 plus 3 is equal to N. Therefore number of circles N is equal to 5. Maybe in our material n square minus 4n plus 5 question is there. What is n square here? 5 square. 5 square minus 4 into 5 plus 5 like that. 25 minus like this given. n square minus 4n minus 25 minus 25. Answer 0 and bit is there in level 1. I think you remember and do the level 1 question. At last, one formula is there. Let us write in the formula way. Formula number 11. Formula number 11. Two circles of radii R1 R2 cut each other orthogonally. Two circles of radii R1 R2 cut each other orthogonally. Two circles of radii R1 R2 cut each other orthogonally. Then the area included between the two circles. Area included between the two circles is capital A is equal to R1 square tan inverse of R2 by R1 plus R2 square tan inverse of R1 by R2 minus R1 R2. If two circles intersect orthogonally like this, you put here 90 degrees, draw like this. This is also draw like this. Put here C2 and C1. Here it is 3 and here it is 2. Put here R1, R2, R2. Depends upon the area. Here integration model is there. R1 square tan inverse R2 by R1 plus R2 square tan inverse R1 by R2 minus R1 R2. In integration model area chapter, using integration we can calculate this one. So we need to calculate like this. Total area of quadrilateral minus sector. This is called as sector 1. And total area of quadrilateral minus sector 2. Total area of quadrilateral formula, we know that R root S11 formula R1 R2 minus this sector area R square theta minus R square. In the R square, theta means tan inverse y by x model, theta means tan inverse y by x model. So for first circle R1 by R1, for second circle R2 by R1. Like this we will be doing. So whenever R1 is the